Hello class, today we're doing the chapter 11 review. So on this first page, what we're going to focus on is looking at mean, although we're also going to be able to identify median and mode as well. So my first question is, if I'm looking at question number 12, number of cards decorated, how am I going to go about finding the mean here? Izzy, what do we do when we're looking for the mean for this problem 12?
When you're looking for mean, you add all the numbers together, and then you divide by how many numbers there are.
Yes, exactly. So just like Izzy said, we add all of the numbers together and then divide by how many numbers there were. That sounds really complicated. You're like, aren't those the same thing? But they're not. They're kind of similar. This is number 7. 9, 9, 9, 10, 10. So we add all of these together. 7, hold on, plus 9, plus 9, plus 9, plus 10, plus 10. And then, as Izzy said, we divide by the number of numbers, the amount of data plots we have. 1, 2, 3, 4, 5, 6. We have 6 data plots. So we're going to divide it by a total of 6. Who can tell me what 7 plus 9 plus 9 plus 9 plus 10 plus 10 is? Perfect. We got great answers from everybody. We got Caesar, Izzy, Isis, Chris, Lucy, Jasmine, Michelle, and Dominic all gave me the great answer of 54. Sorry, my pen is acting up as normal. So for that top point, they got 54. And if we divide 54 by 6, as we do, we get 9, as said by Caesar, and I know that we can do it. So the mean number is 9. Our average is 9. Now, I've got another question. In this case, what would our median be? What would the median be? So first, who can tell me how to describe the median? What is the median of a set of data? Fernando, what is the median? How do we find it?
You order the numbers from least to greatest, and then you cross out all of the numbers until you only have one.
Perfect. So we order them from least to greatest, and we cross them out until we only have one left. Do we just haphazardly cross them out? Do I cross them out, boop, 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 like from least to greatest? Because he's great. He got the ordered set right there. Everything so far he said is great. I just want to know, how do I cross them off? Because I cross them off in a specific way. And what's that specific way? Lucy says on each side. Exactly. So we cancel out one of the biggest, or technically that's one of the smallest, one of the biggest, one of the smallest, one of the biggest, one of small, one of big, until we're left with a number in the middle. So let's look here. I'm going to cancel smallest right here. So I get rid of that 7. I get rid of a 10. I get rid of that 9. I get rid of the 10. Get rid of the 9. And I'm still left, technically there's 2 9s in the center, but since they're both 9, we find that our median is 9. And then lastly, what would our mode be? What is a mode in general? What's a mode? And it's not the way we turn it, like, we're not like in the TV mode or anything like that. So what is the mode? Describe the mode to me with words, not what the answer is. Michelle is correct. It's the number that repeats the most. Hannah says it too. Any number that repeats the most. Exactly. 7. Well, let's look. 6. No. 7 only has one number. No. 8 does not. No. 9 has 3. 10 has 2, so it's already less. No 11, no 12. So our mode is 9. Awesome. Hey, our mean, median, and mode are all 9. Awesome. So that way I know that every time I have a problem, my mean, median, and my mode are all the same thing. Always. They're always the same, right? Isn't that how it works? Good. I'm getting a lot of no's there. Exactly. No. This is just happenstance that it worked out like this. But it is not always the same thing. In fact, they could be far from the same thing. And that's something we're going to come into contact with later. So let's look at this one. We want to find the mean number of tickets. So we already know how we do it. We identify the numerical value of all of the numbers, aka how much they are worth of this, and then we divide by the number of those numbers. It sounds so complicated, but simply, we're adding that. 24. Look, this is how I like to think about it, to make it easier. 24, that's one number, plus 26, that's another number, plus 27, that's another number, plus the last 27, it's over to the side, that's another number. So we see all of that. That leads us to our total of, and I want to write it so that we can see it better, 24 plus 26 plus 27 plus 27, and we had a total of 4 numbers. So when we add all of those 4 numbers up, as Lucy wrote, which I'm really proud, we get 104. Exactly. She did a really good job. I'm going to show you a quick trick. I look at these and I know that they're really close to 25. They're all pretty close to that 25. So if I added up 25, 25, 25, 25, I'd get 100. Now, 24 and 26, that one together I get 50. And then 20, 27, 27, I get 54. So if I add them together, I get 104. That's just a quick way that you can do this. So then you want to divide that 104 into 4 different groups. So when we split it, we know 100 split into 4 groups. That's 25. We've got 4 left over to split into 4 more groups. That's just 1 more. So when we split 104 into 4 groups, as Caesar, Michelle, Chris, and Isis have so far written, and not saying that others haven't gotten it, but it's just what they've written, we get the answer of 26. That's great. So we get this answer of 26. Now, what would our median be? This one's trickier. Let's actually look here. I want us to get this down because sometimes this is easier. Mean, median, and mode. My favorite is mode. It's definitely the easiest to get. So we know our mean is 26. What's our mode? What's the mode that we have here? Modes are my absolute favorite. So for our mode is the most common number. I've seen all of this. Liana, Daniel, Tobias, Jasmine, Ani, Fernando, Isis, Christian, Caesar, Lucy, all of you guys correctly answered. It is 27. So now we got to do the median. Hannah got the mode too. Now, the median, once again, we're crossing off the biggest and the smallest. So they're nicely ordered already for us. So let's cross them off. 24, 27. Oh, but we already have 2. What happens if I have an even number? I don't have a number specifically in the middle. Perfect. Does that mean that my median is 26 and 27? Awesome. We're done. We Gucci. We're good, right? Yeah? Yes, look at all this. We get so many no's, nopes. Exactly. We got to find what's in the middle. That's what we said. Lucy said find in between. We see that Michelle and Christian have given the answer. What is it called? What are we doing to those 2 numbers, to 26 and 27? We are finding the what of those 2 numbers. Exactly, as we said, Jenna, Fernando, Lucy, we see this. They said that we find the mean. Michelle said that. We find the mean. So you find the mean of those 2 numbers in the middle. That's why median can be a little tricky. You organize them from least to greatest. You cross off until you find the middle. If there are 2 numbers in the middle, you then have to find the mean of those 2 numbers. I'll give you a hint. If the number you're trying to find the mean of is between 2 integers that are consecutive, aka right next to one another, such as 26 and 27, they meet in the halfway point because the mean is halfway, which means that our median, as has been stated a lot above, congratulations guys, is 26 and 5/10, 26 and a half. So we meet in that center part right there. Now look at that. Mean, median, and mode. None of them are the same, but they're all pretty close to one another. So we see that our mean is 26, our median is 26 and a half, and our mode is 27. So let's find this one. The table shows the approximate heights of some of the tallest U.S. trees. It asks us to find the mean of the data, but I also want us to find the median and the mode as well. So I want us to find the median, and I want us to find the mode. So I'm going to call on certain people. Don't type it in the chat. So we have some conflicting answers, which is great because that means that we've got some ideas going around. Now, the mode, I always remember it because mode is the most common number that we see. Mode, most. They both start with that mo. So mode is the most common number that we see. Let's check which of these is the most common one. 160, okay, we see that once. 320, okay, we see that once. 100, okay, we see that once. 110, okay, we see that once. 200, okay, we see that once. 220, okay, we see that once. What? Yes, Dominic, exactly. So there is no mode. It is entirely possible, in fact, highly likely, that you're not going to get a mode. What about a median? This has no mode, so let me guess. It also has no median and no mean, right? It has no median and no mean. Am I correct on that? Perfect, I got some replies. No, just because it has no mode does not mean it doesn't have a median or a mean. In fact, we always have to have a median and a mean. We always have to have those. It's just the mode that it might not have. So now, for a median, let's come in. We've got someone, Lucy said she got 180. Once again, I'm not sure. So let's look. We could write them out and organize them from least to greatest, or you could just look carefully. And by look carefully, I'm saying literally like even I have messed up. So first you find the biggest number, 320. So I'm getting rid of that. Then the smallest, 100. Then 220. Then 110. Then I've got 160 and 200 in the middle. And I have to find the mean of those two numbers, which is 160 plus 200 divided by 2. That's going to be 360 divided by 2. 36 divided by 2 is 18. I know it's kind of in the bottom, so you can't see it very well, but 36 divided by 2 is 18. So that means that 360 is 180. So our median, as Lucy said, is 180. So then we've got our mean. Now we've got to follow that same thing, except this time we got to add up all those numbers. So we add up 160 plus 320 plus 100 plus 110. I'm using my calculator because why not? Plus 200 plus 220. And when I add them all up, I get this really, really pretty number of 1,110. So we get this. We count our numbers. 1, 2, 3, 4, 5, 6. We already knew it had an even amount of numbers because it was an inconvenient median to find. We divide it by 6, and we get our answer to be 185. Excellent job, everybody. Great job, Lucy. Great job, Michelle, for giving me the mean. I don't know if somebody else gave it earlier. I think it was just Lucy who gave it earlier, too. But thank you. You guys did really, really well on that one. Now, find the mean, median, and mode if the Coast Redwood is not included in the data. So I'm going to ask Brendan, what's the new mode? For the first one, there is no mode. And now we want to get rid of the Coast Redwoods. Boop. That one's gone. So now, Brendan, what is our new mode? What is our new most common number? Exactly, Brendan. Still, there is no mode. There is no more, there's no more numbers. Median for this one. This one's so much nicer because it's an odd number of numbers. Makes my life so much better. Makes your life so much better. Makes everyone's life so much better. So we just cross off from biggest to smallest. That's our new biggest. Same smallest. This one. And then smallest. So we get 160 to be our median. As we see, I just crossed off biggest, smallest, biggest, smallest, biggest, smallest until I got it. And then the mean. Now, I add them all up. I add up 160 plus 100 plus 110 plus 200 plus 220. And what number am I going to be dividing by? This is the part that I want to make sure all of you know. What number am I going to be dividing by? Excellent. So as we got from a lot of participants, we divide by 5. Isis got the top part to be 790. She added them all up. She got 790. We then divide it by 5, and we find out, as several of our guests have so far said, our mean is 158. Let's look at that. How does the height of the Coast Redwood affect the mean of the data? It changes it a lot, right? That's an almost 30, feet, an almost 30-foot change. Try to picture that. I'm 5'7", so imagine about 6-ish, or 5-ish of me standing on my shoulder. No, 6-ish of me standing on my shoulders, approximately that. Boop. Like that much. You know? It's a lot. Imagine 30 Subway sandwiches lined up. It's a lot. So that's a big difference. Even our median changes a lot by 20. That's a whole lot. So that changes, it skews our data by a lot because it is so much larger. Look at this. All of the other ones are in the 1 to 200 range, you know, high, like low to mid hundreds and then low 200s. And this one's way up there. It's 100 higher than any of the other numbers. So it makes the mean and median greater. So that's literally how you would answer it. It makes the mean and median greater. It does the skewing. So as we've said before, we've already gone over this. Mean, that's going to be the average. So it is the sum of the numbers divided by the amount of numbers. The median is the middle or mean of, my pen is not working, hold on, middle number in an ordered set where it goes from least to greatest. And then mode is most common. So this is on page 823 right now. Oops. So page 823. You guys should know this stuff already. So what we have here is just an explanation of what mean, median, and mode is, what we just went over in the last section. The middle or the mean of the middle number / numbers in an ordered set from least to greatest. The mode is the most common. We see all of that. I want you guys to look at this one, number 14 on page 823, and I want you guys to solve it. So I want us to find the mean, the median, and the mode. Might I recommend finding the mode first, as it is always the easiest to find, followed secondly by the median, and then lastly by the mean. Exactly. So we see that Dominic said 100. Marcus, Daniel, Dominic, he said 45. Liana, Lucy, they all said, and 85, They are correct. Hey, what? But we have 2 modes? How is that possible? Perfect. As Eurene, as many of you said, the most common are the 100s and 85, 85. Perfect. So it is entirely possible to have more than one mode. What's cool about mode is that you can not have a mode, have one mode, or have infinite modes. Mode is kind of like the one where it's like it's like the wild card. You really never know what you're going to get with mode. The only thing that makes it nice is that it's the easiest to find because you can just look quickly and you can see no repeated numbers, no mode. One set of repeated numbers, that's the mode. 100 sets of repeated numbers, terrible. That's the mode. But they all have to be the most repeated. The most repeated. So then our median. Like I said, we gotta go and we gotta find the middle. I already look at this and I was already unhappy because I can see there's an even amount of numbers, which means I know I'm gonna have to find the mean of the middle numbers. So let's just go about our business and cross them off. 100 is our biggest. Then we got 65. Then we got 100. See, I'm being really careful because I know I was gonna mess up and I almost did. 75. Then we got 97, 77, 95, 80, 82, 87. And so we get that one. We now have the, lucky for us, what we get is our 2 numbers that we're left with are the same number, which means that if we add them up and divide by 2, we just get 85. So now, inconveniently, we have the mean. Who has the top number? Who has the sum of all of the numbers for the mean? So Isis told me the amount of numbers. There are 12 numbers. And I'm going to tell it to you. Lucy told me how much they add up to. If we used our calculator, once again, don't worry about this. We get 1,028. we're going to divide that 1,028 by 12. 1,028 divided by 12 gives us 85.666666666. So we get 85 point, let's just say 67. Look at that. Our mean, median, and mode, at least one of our modes, they're all pretty close to one another, which is great. If we were going to be relying on one of these to tell what the test score was, we want to say, okay, what is the normal test score? Would I say it's 100? Because that's one of my options. 100 is one of my options. Would that be a good option to pick? Yeah, probably not, because it doesn't reflect a lot of the data. We've got those 85s everywhere else. We would say most students, which is our mode, scored 85. Or on average, students scored 85. Stuff like that. Let's look at this. Find the median, the first and third quartiles, and the interquartile range. Quartiles. Oh Lord, do those sound tricky. But they're not as tricky as you would assume. So now, the first thing that we need to do is we need to organize them from least to greatest in order to find the median. Just to make my life easier, I'm not going to write the decimals afterwards just because I noticed that none of them have the same thing, but that's just because I'm lazy right now. So we got 13, the next smallest one we've got 19, the next smallest one we've got 23, 24, 28, and 29. Excellent. So when we have this one, we organize it. We find our median. We want to cancel off 1, 2, 3, 1, 2, 3. So the median is right there. That's the mean of these two numbers. Hey, 23, 24. Although let's look at the actual ones because it's 23.95 and 24.59. So we add them up. Use your calculator and divide for me. Ooh. So for this one, when we do it, we did it. We are going to get 24 and 27 tenths. Now we gotta find our Q1 and our Q2. Here's how I like to do it. I literally break up our data into two sections, one on either side of the mean, or the median, one on either side. And then I find the new median. In this side, our new median, the one in the middle, boop, right there. So our Q1 is that 1999. In that case, what would our Q3 be? Which number? Excellent, everybody. So those who identified it, yes, we get our answer to be that 28. Actually, I'm going to write it a little differently. Q3 is 28.95. And it asks us to find our interquartile range. It asks us to find our range. Hey, who remembers what range means? What is range? Exactly. So our range is our biggest number minus our smallest number. So in this case, our biggest number is that 29 and the smallest number is that 13. But what two numbers am I actually going to be subtracting? What two numbers do I care about and why do I care about those? Tell me the key word that tells me why I'm caring about two specific numbers. Excellent. So as Lucy said, it's going to be Q1 and Q3. And why do we know that those are the two numbers we care about for range? What is it, that word that we care about, those two numbers from range? Caesar and Lucy told me the numbers. Why is it that we care about those numbers for range? Yes, Jenna, it says interquartile range. So we don't care about the range of the whole data. We just care about the interquartile range. Once again, it means biggest minus the smallest. So our IQR is going to be that 28.95 minus that 19.95. I think that comes out to, what is that? When we do our subtraction, we get it to be 8 and 96 hundredths. Now we deal with something with our interquartile range. I'm going to put it up here so we can see it better. We deal with something with our interquartile range. What do we use that interquartile range for mostly? We use it to identify something. What is it that we use to identify? I have since been corrected by everybody. Thank you, guys. So we find out that our actual interquartile range, much nicer, is 9. Thank you, everybody who corrected. I really appreciate it. And Ani got 9. Thank you, guys. What do we use that interquartile range for? What do we use that 9 for? I'll give you a hint. If you watched my videos, you might remember a certain figure who goes, Miss Diaz is lame. What'd they do to that guy? What'd they do to the guy who was lying about it? Yes, Michelle. It's the outlier. They were saying, Miss Diaz is lame. And they go, we want that liar out of here. So outlier. Now, just as a side note, the outliers are a number that is 1.5 times the interquartile range outside of either of our boundaries. So if we did this, 1.5 times 9 gives us 13.5. Let's check for any outliers. So we're going to add, so our outlier has to be plus or minus 13.5 of the Q1/Q3. So let's check. For our Q1, if we add that 13.5, that goes way above. So none of the ones above are outliers. They fit within our group. If we subtract that 13.5 from 19 point whatever, we get 6 point something. All of these numbers are within the system. We don't have any outliers in this number. Excellent. We don't have any single outlier. Now we want to find mean absolute deviation. It sounds really tricky, but we see those words for the mean absolute deviation. This page that we're working on right now is number 16 on page 843. So we see the word mean. That means we're trying to find the average. We see that word absolute deviation. Absolute, we think absolute value. So we're trying to find the average distance between each data value and its mean. So first things first, we want to find the mean of these numbers. So I'm going to add them all up. We don't care about any of the others. We don't care about median or mode. We don't care about that. We add them all up and we find that our mean is 8 3/10. So we add all of these numbers up for number 16. We found that it's, we divide by 10, we get that our mean is 8.3. Then we just simply have to find the distance, it's super annoying, between each of our points. By the way, as a side note, our mode would be 8 because there's 3 of them, but we don't care. So we find the difference between each of them. What that means is that's 14 minus 8.3. That's 8 minus 8.3. That's 7 minus 8.3. That's 6 minus 8.3. That's 5 minus 8.3. That's 10 minus 8.3. That's 11 minus 8.3. And then we have 8, 8, and 6 again, so we just have to count those again. So we have the 8, 8, and 6. Now, you're looking at this, you're going 7 minus 8.3, 8 minus 8.3, 6 minus 8.3, 5 minus 8.3, we're going to get a negative number. That's why it's called mean absolute, because we are finding the absolute value. So it can only ever come out positive. So, using our calculator. Perfect. So, Jasmine got her answer to be 2.7. We've got Urine, his answer is... I'm trying to erase it. Oh, that's because that's not even what I'm supposed to be doing. Urine got 2.7. Let's see. Isis, here, she got 1.7 or 1 7/10. Let's see what else. Who else has answered so far? Tobias got 1.7. Chase got his right. It is 0.3. Let's see. I'm probably missing. Perfect. Chris got that 5.7. So, Tobias, I'm just going to show you. If you do the subtraction, 7 minus 8.3 gives us a negative, but it's going to come out with 1.3. Tobias, you're right. I'm so sorry you said that. We got a question here that says, it's negative. Yes, it is negative, but we see that word mean absolute. Absolute value means it always comes out positive. So all of these answers come out positive. For Hannah's, I'm just going to contribute it because I think she might have bippity-bopped. So it is going to be 3.7 that we have. So Now, we also have that other 8. The 8 is 0.3, the other 8 is 0.3, and our other 6 is 2.7. To find the mean absolute, we add all of these together. I know. And then we divide by how many different numbers there were. So let's add 5.7 plus 0.3 plus 1.3 plus 2.7 plus 3.7 type 7 plus 1.7 plus 2.7 plus 0.3 plus 0.3 plus 2.7. I think I added all of my 10 numbers together. Then I divide by the number of numbers I have. I divide by 10. So for this one, I add them all together. I get 21 and 4/10. There's 10 numbers. I divide it by 10. I get 2.14. The book says it's 2.02, so maybe that's the answer. But as many of you guys said, don't trust the book. I don't trust this book at all. I just use it as to confirm that I'm right. And then if I don't get the same answer as the book, I trust myself more. So we see that. So we know that our literal mean deviation is 2.14. That means on average, each number is about 2.14 away from the mean, which makes sense. 6 is about 2 away from the mean. 5 is still about 2 away from the mean. That 11, that 10, those are still pretty close. 7 is only 1 away, but 14 is much further away, and these are really close. So they all average out. That's why it's mean absolute. They average out to get us that 2.14. Our last thing, which isn't really something that we're going over specifically, the game I like to call mean, median, or mode. This is when you try to look at a set of data, you identify the mean, median, and the mode, and you try to determine which one is the best to use for your data. So I'm just going to give you a couple examples, just free examples right now. So for this one, mean, median, mode. We're going to play a quick version of this game. So, mean, median, and mode. For my mean in this one, I'm getting 20.6. For my median, I'm getting 10. And for my mode, I'm getting 11. Which one of these might be one we don't want to use? Which one might be one we don't want to use? So I got a couple answers, but yeah, we don't want to use that mean. Look at how different it is from all of the other numbers. Median and mode, those are really close. That means our data set is probably more accurate than when we have it like that. What about if I had this one? If I had this problem? If I had 17 as my mean, I had 18 as my median, and I had no mode. Which one do I not want to use here? Which one do I not want to use? Exactly. It should be easy. We don't want to use the mode. The mode is useless. There is no mode. Now, what if I had something like this? Okay? So I had a mean that was like 86, a median that was like 100, and a mode that was like 220. Which one do you think I'm not going to use? Which one would be a bad one to use? Yes, exactly. So we don't want to use that mode again because it's just an outrageous number. So just to remember, we want to use our means when the data has no extreme values. What that means is that we have, 1, our data was like 1, 3, 7, 11, 15. There's no extreme values. No one's just crazier than the other one. Then we want to use the median. Data has extreme values, but there are no big gaps in the middle. So for example, we would want to use it if we had something like 2, 5, 100, 110, 113, 400. In that case, we'd want to use the median. And then the mode is when the data has many repeated numbers, such as like temperature a lot. We want to use mode with temperature. We want to use mode with prices. That's really helpful. We want to use mode with all of that. That's the kind of best stuff that we're using. Essentially, you find all three and you look at which one is the outlier. I know it's a lot to take in for one chapter, but the main points that we care about, the main things that are of the greatest importance are knowing how to do and how to use mean, median, and mode. Additionally, knowing what Q1, Q3, and the IQR mean and how to find them is important as well. But our main focus, the main focus that you'll have in years to come, is being able to identify, know the difference, and solve for mean, median, and mode. Good luck on your test, you guys!